Hello everybody, this is Mrs. Landry. I wanted to show you how to use these yellow and red counters, and I wanted to do it, I'm going to show you kind of an informal lesson because I don't have the luxury of being at school and on my beautiful board, so I'm kind of in my kitchen and I'm using my refrigerator because I have these magnets. These magnets are the same as what you guys have. This is a counter that is yellow on one side. I don't know if it's showing up well. I think the light's kind of bad to show it very well. But this is a yellow token, yellow counter, and on the other side it's red. The yellow represents positive numbers, and the red represents negative numbers. So we always think of red as being negative when we're talking about these things. Now, if I had several of these yellow ones, these are all supposed to represent 1, and you can just count this and see how many you have. You have 1, 2, 3, 4. When we talk about these numbers, 1, 2, 3, 4, those are what we call our counting numbers. Those are our natural numbers. Those are the numbers you've grown up counting all the time, all right? So that's what we use throughout elementary school and that sort of thing. That's what you base all of your arithmetic lessons on. Then all of a sudden come these guys. And when we start talking about the positives and the negatives and zeros, that's what we call integers. So I'm going to write that word down because I want you to see it and understand. Integers is next level when it comes to numbers. So, you see that? Okay. So integers are what we're talking about when we're talking about positive numbers and we're talking about negative numbers. Now, I'm trying to mimic the number line, and you guys have seen a number line. I thought that I could show you one here on camera, but unfortunately, it doesn't show up very well. So, but you know, you're familiar with number line, where we count just as you would when you read words in your C therapy. You go, you know, I read from left to right, we read from left to right. We're going to count our natural numbers from left to right. So we would say 1, 2, 3, 4. But when we start talking about our negatives, we count those backwards according to the number line. So this would be -1, and this would be -2, and this would be -3. Now, of course, these are objects. This isn't a real number line. So it doesn't really matter what order I count them in. This is 3 reds, no matter how I count them. These are 4 yellows, no matter how I count them. But throughout this little bit of a lesson, I'm going to try to remember to do my yellow numbers going from left to right and my red numbers from right to left. Okay? So those are kind of that's the basics, the very beginning before we actually do anything, is understanding that. The next thing I need you to understand is that we're going to have what's called 0 pairs. I'm going to write that for you because this is the key to understanding how these integers work and how we add them. 0 pairs. 0 pairs mean what you would think that they mean. You get the number 0 when you pair them up. So what happens is, if I look at my numbers, like a +1 and a -1, together these two numbers make 0. +1, take away 1, means that I have 0. So this is what we call a 0 pair. Okay? 0 pairs can also be the numbers 3 and -3. Those also add up to 0. So, and if you think about this, not talking about with objects, but if you think about this in terms of like distance, if I take a step forward and take a step back, I've not really gone anywhere. So that's kind of the idea of 0 pairs. So let's talk about addition using these objects. Okay, so if I'm adding up objects, and again, we've been counting stuff our whole lives, so we know how to count things. That's kind of simple. So if I had something like Oh, a good old basic math problem. 2 plus 3. Of course you know what that is. You don't need to have a bunch of tiles and a bunch of silly stuff, but I want to show you how this works, because when we understand this with small numbers, this can be extended to big numbers, and it can kind of make things make a little more sense. Because negative numbers, like I mentioned to you guys earlier, are not easy. The two things that I see that are the biggest holdover struggles from middle school going into high school, always fractions. Fractions are so hard that even adults still can't do them. And negative numbers, those are the two things. And you're going to see both pretty frequently in high school. So that was 2 plus 3 is what I wrote down. So how would I represent that using these counters? Well, I would have 2. I would have 3 more. I want you to always think of addition as more, because it means I'm continuing a journey. I'm going and taking more steps. Sometimes those steps are going to be forward, and then sometimes you're going to see that they go backwards. But plus always means more. So I'm going to write that down. That's important stuff, so I want you to understand that. So what happens when I have 2 plus 3 is I have 2, and then I have 3 more. So I have 1, 2, 3, 4, 5, total of 5. And you're like, that's total baby stuff. Quit wasting our time. Let me show you where it gets a little bit more complicated. Okay. Well, what happens if I have -2 plus -3? Okay. Now this, for students, gets to be a little complicated because now we're bringing in negative numbers. And so it gets kind of confusing, and people are trying to minus things and trying to figure things out. And I want you to keep in mind that with these tiles, or these counters rather, it's really kind of a simple process. Negatives are represented by the red. So I have 2 reds. And then I have 2 reds. I have 3 more over here, which I'm talking about if I'm taking a journey, I would write it that way. Or I can think of this as -2 and -3 more. Either way, it's going to be the same. So I have -1, -2, -3, -4, -5. I have a total of -5. So -2 plus -3 is going to give me -5. Now I want you to notice that that I used there the commutative property. Commutative property is one that you use all the time, and you don't think much about the name, but I guarantee you, come high school, you're gonna know all of these names of all these weird things. So commutative property is the property I just showed you. I get so confused going backwards. I have to do a backwards camera. So commutative property tells me that -2, doggone it, plus -3 is exactly the same thing as -3 plus -2. It doesn't matter what order you put them in. But again, for our purposes, we're going to continue to think of the plus sign as a more move, like you're going to continue on your journey. So all this right now is just a bunch of words I'm saying, but let me get you to where we're trying to go. Let's just say that now I'm trying to figure out what on earth is 5 plus -8. Okay, 5 plus -8. That's something that's a little bit different. I've got 2 different numbers going on, or 2 different signs going on, so it's kind of, well, I don't know what that's going to be. Well, let me show you what this looks like using these counter tiles. Okay, so I have 5 yellow tiles. 1, 2, 3, 4, 5. Okay, and I want to go 8 more, but I'm going to go 8 more in the negative direction. So I keep dropping these things. I go 1, 2, 3, 4, 5, 6, 7, 8. So I've made this journey. I went 5 in this direction, and then I went 8 in this direction. So right now that doesn't tell me a whole lot. But then I think to myself, oh yeah, there's 0 pairs going on here. These two add up to 0, so I can just take those away. These two add up to 0. I can take those away. These two are 0. These two are 0. These two are 0. So if I don't look at all those zeros and I just pretend they're not there, I really have 3 reds left. And those 3 reds are -1, -2, -3. So I have 5 plus -8 is equal to -3. Okay? Whoop, there we go. So that's basically the gist of what I do with these things when I'm doing addition. And addition is a little bit easy. Subtraction is a little bit hard. So if you practice this a few times, and I'll practice a couple more times. If you practice this a few times, you get a little bit better at it, and you start to see it a little bit more and understand a little bit more. Like, oh, okay, now these are going to make 0. So, and I will show you what this looks like on a number line, and I will show you what this looks like with equations. But I want you to first just think about this with these guys, because these are a little bit easier to manipulate and hands-on, and you kind of get a better sense of things. So let me also look at this now. I'm going to do the same exact thing that I've been doing, but I've been pretending that I have a horizontal number line. I'm now going to show you what it looks like if I pretended that I have a vertical number line. Turns out it's not very different. So let's say I've got -4 plus 8. Now let me give a different number. -4 plus 9. Okay, so this is my equation. Now, of course, some of you have done these things thousands of times and you already know the answer. And so this isn't for you. But my friends who really still struggle with it, I want to show you what happens. Again, I'm pretending like I'm doing a number line. So if I did a horizontal number line, I count positive going this way, I count negative going this way. With a vertical number line, I count positive going up, I count negative going down. Generally speaking, when we have students with dyslexia, we like to focus on the vertical number line because the vertical number line will never get you confused. It's always positive going up, and kids can remember that. But the right, left of a horizontal, it gets kind of mixed up with mirror images and stuff. But anyway, so let's talk about this -4 plus this positive 9, and we're going to talk about it using the vertical number line. So if I'm starting with my first number, my -4, that first number, by the way, has a name. We call that an addend. It means the number that's going to be added to. So, or we can call it an addend. But anyway, so I've got -4. I'm going to count it going down. -1, -2, -3, -4. I started my journey going down. Now I have to continue my journey. I'm going to go more steps, but I'm going to go 9 in the positive direction. I'm going to go up. So I'm here. So I go 1, 2, 3, 4, 5, 6, 7. Uh-oh, I'm almost out of camera space. 8, 9. My ice maker just dumped some ice. So that's lovely. Okay, so here I've got 9 going up, 4 going down. And again, I think to myself, oh, wait a minute, 0 pairs. This is 0. And this is 0. And this is 0. And this is 0. So I'm left with, where you can see it, 1, 2, 3, 4, 5. So -4 plus 9 is equal to +5. Okay, I hope this is showing up. It looks weird on my angle. Okay, so I wanted you to see that because I want to do some work with that. And I want to continue this when we do subtraction, which is the next level up. So subtraction gets a little bit more confusing. So I want this kind of practiced a few times before we go into that. If you can do this really well, in 2 years when you're in Algebra 1, we start doing stuff with our algebra tiles, and we start having all these positive and negatives happening, we're going to use similar tools. We'll use little algebra tiles that are square, and it'll make so much more sense to you because you'll be used to doing positives are yellow, the negatives are red, and you'll have a better sense of it. So I like doing these. Again, I don't know exactly what your other teachers in the past have taught you, but this is what I like to use as a manipulative. Okay, so I'm going to stop right there because I've talked a very long time, and I'm going to do another video where I show you how to use the number line and actually write on the number line to represent the same sort of things that we just did, and see if it makes sense to you. Okay, so let me sign off. I keep dropping tiles everywhere. So let's see. Thanks for playing along.